Hi all, many thanks to be here for this presentation about our product, ScanEasy tool. My name is Pierre BLAZINCIC. I'm in charge of the engineering at Testia. First, a quick introduction on ultrasonic inspection. The inspection for aerostructure component become more and more automatized with specific machine. Despite this evolution, many inspections are still done manually by the inspector. In fact, manual inspection is done due to the complex geometry of parts, the large round of parts, and also due to the rates of production. The inspection must be done, The inspection of parts must be done on all the surfaces. No area must be missed. Our main objective is to provide some solution to the nearest of the shell product, with the target of cost reducing while also improving the quality. Before starting the presentation, a quick look on Testia company. Our core business is focused on the inspection of aerospace components. With 4 pillars: training, inspection, advice, and development, we are able to provide some products which are innovative and efficient. Basically, I mean we can collect information by the feedback of our inspector and our level 3 services and develop new products with our product team. In this presentation of the ScanEasy tool, we will see the context to understand the constraints, then the existing solution, and why we have developed a new product, and we will finish by the possible adaptation on the ScanEasy tool. Let's start to the context which brings us to develop the ScanEasy tool. The context is based on concrete application from one of our customers, but also on our knowledge of parts in aerostructure. First, we determine the range of parts to be inspected. The size of parts must have no influence, so we consider all sizes, from small parts to large parts. We also have to keep in mind the different geometry of parts. For example, radius areas and juggle areas. Then, the accessibility of parts can be difficult on more complex parts. Finally, we also consider the evolution of the structure. It can be thickness evolution of addition of layer protection as glass ply or metallization. The range of parts is now determined. To continue, let's have a look on the quality. We have to follow the customer requirement for the quality and traceability. The customer requirement for non-destructive inspection on composite parts is mainly turned towards the UT inspection, and we are looking for defects due to the manufacturing process, as delamination, volute porosity of foreign object. Another point is that the specification defines the traceability. We must record and report some key information during the calibration and during the inspection. For example, the device inspection game. The last point that we want to consider is the human factor. We can't take any risk to miss a defect during the inspection. Now we fix 3 cases for the ScanEasy tool. The next step is the cost reduction. In fact, the inspection time is a major issue for the cost reducing. That's why we have to find a solution for the fastest inspection. In addition of all these constraints, we think it's necessary to have a flexible product. I mean a product registered in a range of products, easy handling for any place of inspection. Of course, some solutions are already available. Actually, there is mainly two kinds of solutions: the manual inspection and the automated inspection. Let's have a quick look on benefits and limitations of these both techniques. For manual inspection, we have access on large range of parts due to the size of the transducer. But because of the concept, this technique is very time-consuming and subject to the human factor. However, manual inspection is cheap and could be done nearly everywhere. About automated inspection, these solutions are often defined for specific parts and are difficult to update for other parts. It could be very inspective and it can't be moved, but it guarantees the quality, reduce the human factor, and reduce considerably the inspection time. It comes as no surprise with our solution, we want all these parameters in green. To study our solution, we differentiate the hardware and the software. Let's start with our choice about hardware. First, we determine the probes and the transducer. For flat area surfaces, we choose a fast array probes for the capacity of large inspection. In fact, a fast array probe is done with small transducer, several small transducers in a line. With this probe, we can scan from 30 to 60 millimeters, whereas the conventional one, it's about 6 millimeters. Moreover, we can see on the drawing the method to scan a part, which conventional transducer, we have to do a cross scan, and we estimate with a fast array probe, we can divide the time by 10. As a reminder, the geometry of parts can be complex. For this typical area, we have to use a conventional transducer. With the association of these both devices, we are able to scan all kinds of parts. We decide to install the software on our tablet U32 Neo. This device is already utilized for other products, and its capacity was proved. Then we design a case for the device. There are also all accessories needed: water coupling, so at this moment, we have seen that we are able to inspect a large number of parts and work everywhere. We are quite better than manual inspection for quality and inspection time, but not efficient as we want. Let's continue with our dedicated software to achieve the ScanEasy tool. Our software team is used to develop dedicated software for UT signal processing. Many tools are recognized and named in the Airbus specification. During the study, we have determined that we had to solve two main challenges. The first one was the management of fast array and conventional UT in one software. Actually, we can't use this problem in the same software. It means we have to use two devices, or one device, but do many operations for an inspection. Operation as calibration, for example. On the next movie, we will see how we can switch between fast array and conventional UT. For example, we start with fast array, then we go on conventional UT. We can go back on fast array. And of course, we are able to switch as many times as we want using the tab at the top of the screen. And we keep the same calibration all along the inspection. So the first challenge is solved. We create a new application for using the both equipment. For the second one, we want to create a simple view for the operator. Actually, to analyze this scan, we need lots of mapping. Our objective was to have one mapping with all required information. For the data analysis, basically, we need 4 information. The gray color is only when the scan is not in progress. So let's say the really first information is the blue color. The blue color is done for trouble of transmission of UT in the part. The next color, the green color, and the most expected is for the area without defect. The orange color for the defect has volume porosity. And the last one, the red color, is for delamination. With only 4 colors that are easy to differentiate from each other, we are able to find all defects required. This view needed a collective work between our software team and UT team to find the safest algorithm. We can't take any risk to miss a defect. Some example of view. On the mapping on the left, we can see clearly a volume porosity, and at the right side, a defect as delamination at the edge of part. The last choice we have done for the smart view is the scanning time. In fact, with this kind of acquisition, the draw of defects stays few seconds on the screen. Actually, the indication stays directly and disappear directly. To expand a little bit more the safety of the inspection, we had a baseline view. This view shows the part in its thickness. Here we can see the delamination. On the left, it's a baseline view, and on the right is a smart view. And then we will see we keep on the smart view, we keep the indication, and the baseline view, it disappears directly. With this both method, we really decrease the inspection time and the minor factor in detection of indication. As many applications that we have already provided, we decided to include a step-by-step inspection on the software. Now we will have a global look on the ScanEasy tool. And at each step of the calibration and inspection, all the information required are recorded for the traceability and for the insertion in the report. First, the operator has to log in. By this operation, we are able to check the due date of the certification. If this date is expired, the operator can continue. Then we insert the serial number of the part. It can do manually or by barcode scanner. And we can see the reference standard associated to the part. And we check also the validity. At the UT certification, if one date is expired, the inspection is blocked. Next, we have to check the due date of the equipment. For example, with an expired date, the bottom is in gray color, and the operator can continue the inspection. Now all equipment are available. We can start the calibration. First, we are checking the probe and measuring chains. On the left side, we can see each element of fast array probe. By the software, we are checking if some elements are effective. Now we are checking the delay line. We can see the amplitude of ultrasonic signal on the left, and on the right is the thickness of the delay line. Then we equalize all the UT shots. It means we must have a constant amplitude on all the width of the probe. Now it's the adjustment of the gain on the reference standard. At the top left is a baseline view, a representation of a part in its thickness. At the bottom left, it's a scan view on one fixed area of the probe. At the right, it's the amplitude on all the width of the probe. And the last window is done for the adjustment of the general gain. To complete the calibration for first-door inspection, we find the smart view. We are checking if we are able to see artificial defect on the reference standard. First, a representation of a defect in a part. Then we will see a defect as a delamination at the edge of the part. The fast-door calibration is done. Now it's conventional UT calibration. First, we do the calibration for flat area, sensibility and detectability. And we will do the same for radii areas. When the both calibrations are done, we go in inspection menu. At every time, a view of the part with a legend is available. As previously, we can navigate on menu to inspect by first door on conventional UT. We start by looking for defect with fast door. We can see a delamination, and if it's necessary, you can go back on the defect to have an advanced view. On this view, we can have more information on the defect. And by manual UT, we can characterize the defect. Another kind of defect as porosity. And we can go back on conventional UT. On this menu, we can see at the top right, we can recall the general gain for the flat areas, but also the general gain for the radii areas. And under this menu, we find a menu to move the gates. It could be necessary for a good characterization of defect. And the last button is to go back on the same setup as the UT setup. When the inspection of part is completed, we can input another part. If the part is in the same range of the previous part, we keep the calibration. To finish the inspection, we can generate a report. We just have to insert the fabrication order number and then start the creation of the report. In this report, we'll find all information about equipment, validity date, the inspector. The operator has just to write the characteristics of the defect. With the tablet, it's also possible to take some picture and transmit the report by internet. Now we can conclude on the ScanEasy tool. A reminder of the benefits and limitations of the actual solution. As we saw during this presentation, with ScanEasy tool, we are able to inspect all kinds of parts. With our choice of hardware and software, we manage the quality, inspection time, and environment. The ratio benefits price is really interesting. To complete this presentation, some possible adaptation. By the conception of the software, the ScanEasy tool is already configurable to add some part, however the structure. It means new UT setup, new reference standard, new equipment, and we have already used this feature. At this moment, we are working to add radii inspection by fast door techniques to divide this kind of inspection. It must be available for concave and convex radii. The UT equipment choice can be done according to the part. For example, we can plug some device as our easy wheel. Finally, our software team can update the software for other specific requirements. Thank you all.